right, so can you find all 6 trig functions of 30 degrees, 60 degrees, or 45 degrees? Yes. You draw the triangle and you figure it out, yes?
Yeah.
Perfect.
Yeah.
Wait, for the 45, it'll be x equals 1, y equals 1, r equals 0.
Yes. Alright. What happens from the other day? We're going to review just a little bit. We'll pretend that you don't remember that. Co-functions. What are co-functions?
Well, they're reciprocals of the actual function.
No.
Sine, cosine.
No. There's nothing that's reciprocal.
So it's like cosine.
Cosine of 28 degrees equals what?
Sine of like 70.
Cosine minus 90.
90 minus
cosine.
28. Okay?
Oh.
So co-functions, you figure out cosine is which co-function with sine, and you're going to take your angle and subtract from 90. So cosine 28 is really sine, was it 62, 72?
62.
Yeah.
It's 62. I thought it was supposed to equal 100.
So these two are equal. Okay? So what happens if I give you something crazy, like tangent of 2 theta minus 18 equals cotangent theta plus 18.
Well, you just solve it.
You're solving for theta.
Do you want us to?
Yes, I want you to solve. What is theta? They're co-functions. I didn't realize we covered this much. We're basically finished with this.
Sweet. See, this having we crack down hard. What?
No, it was just my memory from 3 days. Did not do well. So we're going to move on. So what did you get? What is theta? How are you setting it up, first off?
Well, 2 theta minus 18 plus theta
Oh wait,
plus
I did this one.
18 equals 100. 90. It equals 90
Why?
because it does. Now,
Because-
science is set.
Because the angles must be complementary. Yes?
Yes.
I'm going backwards just a second. 28 and 62 have to be complementary. 28 plus 62 is 90.
I found it.
Okay?
There was no angle by time.
So I just went back.
Okay.
So these two angles, actually the first thing you need to know is tangent and cotangent are related how? They're co-functions, and all co-function angles have to be complementary. Yes, yes.
Wait, once you do your theta, you just plug it back
Nope, you're done. All I want is a theta.
in. You don't plug it back in.
Oh, well.
You could. You don't have to.
Will we ask us to do that?
Did you get theta equals 90?
No, theta
30
can't
is
equal
30.
90.
Sorry, theta equals 30.
Yeah. So you subtract and add, so you have 3 theta equals 90. Theta equals 30 degrees.
See, Miss Evans, it's dumb mistakes like this. Like, give me an 88.
I'm sorry. It's okay. All right. We are going to move on because we have plenty of time to 2.2.
Sweet.
I think 2.1 was all about acute angles. Okay? So we're going to move into another quadrant. Okay? Of non-acute angles. Can we find trig functions of non-acute angles? Now the fun thing is we've been doing this, but you haven't really known. You've asked questions, but I'm like, oh, we'll talk about that later. If I have an angle in standard position, my initial side is on the x-axis going positive.
Right.
If I now have a non-acute angle, means I'm going at least into the second quadrant. So I'm just going to go to the second quadrant, terminal side, in right there. I have an angle, theta, that is right here.
Wait, not exactly the 7.
Not exactly what?
It could be on the y-axis. Then it'd be 90. Because an acute angle is anything less than 90. So couldn't it just be on the y-axis instead of all the way in the second quadrant?
No,
Why?
because obtuse is more than 90. I want an obtuse angle. And if it's on that, we've already talked about quadrantal angles. Okay? We've already talked about that. We'll talk about it again another day.
No.
So I want some obtuse angles. We're going to the second quadrant. So every time we did this, where did we draw a triangle to? The x-axis. So I'm drawing with a different color. We drew it down, put an angle, a right angle there. And where was our triangle? And where did I tell you we were putting theta?
In the inside.
In the inside part. Okay? I'm going to tell you right now, we're getting more specific. They're going to be theta primes, and we call them reference angles. Yes. So a reference angle is your theta prime. It's going to be an acute angle. Okay? Let me just say it. Always acute. Every reference angle will be an acute angle. Okay?
Because you don't have a single obtuse?
Not necessarily. We can have a reference angle. We'll do one in a little bit. Okay? If you are in the second quadrant, so I'm going to put a quadrant 2. How are we going to find our reference angle right here? Zach already said it, something about it. Can we subtract 180 minus theta? Okay? Actually, I'm going to not put an equal sign in this
What
spot.
if you don't know the theta?
I have to give you something. Okay? So we'll do one in a minute. We'll equal our theta prime or our reference angle. So if I give you, if you want me to go ahead and give you a number, if I give you theta equals 152 degrees, can you find theta prime? You're saying 180 minus 152, your theta prime is that right? No, 38. Oh.
Gosh, guys.
Right, 38. It should be 28.
Oh yeah.
You people, y'all are just messing me up. I'm just going with whatever y'all are saying. Apparently my brain.
That's not what it's supposed to be, Miss 7.
I'm just going by whatever you say.
We're supposed to go wherever you say.
No.
Yes, you're the teacher.
What if I draw theta into the third quadrant? So now I'm going to take this. Oh.
270.
No, stop. So here's my theta. It's going into the third quadrant. Okay? Where am I drawing my triangle to? Every single time. The x-axis. So when I draw an angle going up, what am I going to? I'm going back to 180, correct? I'm never going to go to 270. Okay? So this instance, I'm going to take my theta.
Theta plus 28 minus 20 minus. I said that.
Okay? So if I'm in the third quadrant, this theta, 212 degrees. So my green theta is 212 degrees. How are we going to find our reference angle that's just this little piece right here?
You would subtract that degree, 212 minus 180.
I think I've got this one.
32.
32 degrees. So my reference angle is simply 32 degrees.
Good job, Zach. I'm proud of you.
Thank you, baby.
You're welcome.
All right, let's see. Can I draw one more?
Yes.
I may draw two more.
No.
Uno más.
So,
Uno más.
initial side, going around into the third quadrant.
283.
You want 283.
Really
Not
want
the
283.
fourth quadrant.
So, fourth quadrant, yes. Did I say third? Sorry. This theta is going to be 283. Not drawn to scale.
Yes.
Where's our triangle? Where are we always drawing our triangle to? The x-axis. What angle is that I'm going up to? So we've gone 90, 180. So we're either going to do 180 or if we go all the way around, 360. So quadrant 4, you will say 360 degrees minus your theta will give you your theta prime. So if your theta is 283, what's 360 minus 283?
Can we change the number?
No, it's too late now. 77?
Because I want to make it difficult.
But do you see all of our theta primes are acute numbers?
Can we do that one?
What if we have an angle that's in the first quadrant? What if we have an angle that's
Subtract.
in the first quadrant right here? And that angle is 48 degrees. Where are we drawing our angle up to? Where are we drawing our triangle? Your angle, your reference angle is 48 degrees. It doesn't change. If you already have an acute angle in the first quadrant,
That's all I'm saying.
it doesn't change. It just stays that number. Yes.
I went on a tour with Brian. When we went, he wanted to no, it's going somewhere. He went to go talk to the computer engineer there because he wanted to be a computer engineer.
Okay.
That lasted all of 5 seconds.
Okay.
And then we were talking to the mathematician. He said, "A good engineer is always smarter than his calculator."
Okay.
That's impossible.
I have told you that a bazillion times. You should be smarter than your calculator.
Yeah, so that's not gonna happen. I cannot do 4,356,283 minus 5. No,
I
sorry.
couldn't.
Minus 3.
Okay, it doesn't matter. Your calculator should be a tool, not a crutch. Does that make sense?
So you
Like, we
use
can
the
translate
for the
it.
job. You don't bang your phone against the nail to put the nail in the wood. You use a hammer. They're making me laugh.
what-
I'm not making you laugh.
Yes. Alright, here we go. So if I give you a reference angle that is more than 360 degrees, what do you have to do? So if my theta is 1,256 degrees, and my question is, what is theta prime?
Quadrant 2.
Well,
Or your reference angle? I actually will use the word reference angle a lot more than I'll use theta prime.
What quadrant is it?
For quadrant 3, why didn't we use 270?
Because we don't ever draw a triangle to the y-axis. We always draw it to the x-axis.
why?
So what are you doing first?
Well, you gotta give us one.
No, I don't.
Why?
You have to figure that out for yourself.
How?
I don't know how.
It's the second quadrant.
How did you find that?
Oh, you do the least positive above. It's the second
Okay,
quadrant.
so going back to chapter 1, the least possible,
Blah,
what do we call that?
blah, blah.
Co-sequences.
Co-terminal.
Co-terminal
Coterminal.
angles. So we're going to subtract 360. And we're going to subtract 360. Probably going to subtract 360 again.
Yes. 3 times.
You get 3.48.
176. So which quadrant are you in?
Uno.
So I need you to know that 176 is a co-terminal angle. Okay? That tells me which quadrant we're in. We're in the second quadrant. What is your reference angle? No.
180 minus.
You're in the second quadrant, so what are you finding? It is 4 degrees, because we all plugged in our calculator, 180 minus 176.
I did it.
Okay.
Hit minus 180.
Okay, you got a negative for it. So reference angles, you can have really big numbers for reference angles. Okay. What if I gave you a reference angle and asked you to find the trig functions of that angle? So could I ask you what is sine of 135 degrees? What's the exact value of sine 135 degrees? Meaning, I don't want you to plug it in your calculator. Do not plug it in your calculator. What are you doing? Draw it out. Where is this angle? Quadrant 2. What is the reference angle? Say that again. What is the reference angle? Ireland, you said what? This angle right here is 45 degrees.
Oh, what a
So-
genius you are.
If I draw this triangle down, what are my side lengths?
What about 90?
Okay, those are angles.
Yeah.
So you got a 1, square root of 2. So what is sine of 135 degrees? We're going to look at what is the reference angle. Do I know what sine of 45 degrees is?
Yes.
Yes, I do. So I'm going to go opposite over hypotenuse. Is it positive or negative? You have to remember, quadrant. All students take calculus. That's never going away.
Positive. Sit there early.
It's positive. Could I ask you the rest of them? Could I ask you, well, what is cosine
Wait,
of 135?
Hold your horses. So it was 1 over the square root of 2, which we have the square root of 2.
So-
Obviously, it's 3 to the top, and then square root of 2 plus square root of 2 becomes 1
I don't know what you're saying.
Okay,
I understand.
yes. I am not going to go slow again on rationalizing, is your answer. I'm not going to do 1 divided by the square root of 2. Oh, I need to multiply the square root of 2 over square root of 2. That's what Zach was walking through.
Yay.
Okay? I'm not going to do that anymore. I want these answers first.
Thank you.
What is cosine 45 degrees?
The square root of 2 over 2.
It's your final answer.
Yes.
What quadrant are we in with 135 degrees?
It is not.
negative.
It was a trick question. Because they should be the same. Okay? But you have to now think, what quadrant am I in? Because the last time, they were all positive. Because they were all in the first quadrant. There was nothing big. What about tangent 135?
Negative 1.
Negative 1.
Negative 1.
Okay? What about cosecant 135?
The square root of 2.
What about secant 135? Over 1. Cotangent 135.
Negative.
Okay? Can you find any of those? Okay. I promise I will not ask you for a long time what exact values are unless your reference angle is one of your 30, 45, or 60 degree angles. Okay? That's the only way you can find those. Okay?
The 7.
Yes.
When I'm in college and I have a math class question,
I've already gotten a text, I promise, this year from a kid who just started.
can I Skype you?
Alexandria. She told me.
Can I FaceTime
Let-
slash Skype you?
I don't know. I'll answer a text message.
But then, you know, can
You get a
that
random FaceTime
text
call from
message
the
be, can I FaceTime or Skype you? Because I'm willing to help, and a professor can only help someone.
We'll see. Alright, I'm going back to problems from 2.1 since we never worked them from last week. So 2.1, we're gonna do numbers.
This is homework.
Yes, this is homework that I'm letting you start early. Because I'm so nice. We got 10 minutes in class to work on it.
Good question, Zach.
11 through 14.
Good question, Zach.
Oh, random extra lines.
Oh, I have an answer if they didn't make any changes. When is that one?
What did you do next week?
Next week.
Oh, it's this one.
Is this Friday?
No, it's this
It's
one.
okay. So it's next Friday.
Numbers, what did
Can you look up what problems for 1.1? And what problems?
Did I finish my test?
Yeah.
I did?
That would be great.
Oh, did I?